Okay, students. Now, when it comes to inequalities, inequalities are very much like equations. I mean, the big difference with an inequality is, this would be an equation, okay? And, well, what makes an equation? You'd see an equal sign. Well, what would be the opposite of that? Well, what if there wasn't an equal sign? I mean, there still has to be something there, though. So, what if you're saying if something isn't equal? Well, if something was equal, here's the difference. When something is equal, you've identified x as just one number, like 2. But if it's not equal to just one number, what's the opposite of that? Well, then it has to be equal to a whole lot of numbers. So let's just say I put an inequality symbol here. Okay, and if I solve for x, x isn't equal to 2. It's equal to everything else other than 2. Well, not exactly, but I'll get into that in a second. So, that's the difference between an inequality and an equation. And, I mean, you solve the exact same way. In both cases, I would divide by 5 on both sides. I would still use the exact same technique. You don't need to do anything different. It's just kind of more how we look at the variable. We're not looking at, when we have an inequality symbol, we're not looking at x being just one number. We're looking at x being a whole range of numbers. So let's get into what that actually can be. So, all right. So let's go back to an inequality. Even though it's an inequality, it might look just like an equation. Now, there's a few different things this can be. And I'm going to leave this blank for now. We have a couple of different symbols here. We have the arrows that point to the left. Okay, that's less than. Oops. And less than, the best way to remember is less than always points left. Now, what if I have an arrow that points left and I have a little bar underneath? Well, that little bar underneath actually stands for equals. So we have two different symbols put together as one. The first symbol is a less than symbol, and this other bar is less than or equal. And they both exist at the same time. So if you see something like x and then you see this symbol and then you see 2, well, x can be equal to 2 and it can be equal to everything less than 2 as well. What are our other two symbols? Well, they go opposite. So instead of it pointing left, now it points right. And instead of it being less, now it's more than. And if you can figure out where this is going next, we also have an arrow that points to the right and a bar underneath. Now we have two different ideas going at the same time. We have more than, and we also have an equal. So more than or equal. So let's put a symbol to this. Let's make it more than or equal. Okay? So I solve this, and you know what? This is going to be really easy because when you're given an inequality problem, they look just like equations, and you solve them just like equations. See, so far so good. This looks pretty easy, actually. Divide by 5 on both sides, and x is greater than or equal to 8. Well, so why even have like a new section for this? Well, there's a couple of exceptions. And there's two things you have to look out for. Now, I got to warn you kids, in years past, kids aren't too good at spotting different situations. And there's two things I need to look for. The first situation that I need to look for is x negative. Now, if x is negative, that means that's the opposite of x. And that's a little tricky for some of you to understand. I mean, the thing is, if I say that, x is more than 2, like that's cool. But what if I say x, the opposite of x is more than 2? Oh, wait a minute. If x is 2, what's the opposite of more than? Oh, it's less than. So do keep in mind, when x becomes negative, we're really saying the opposite of what was said to begin with. If you have the opposite of x is more than 2, well then the opposite of that would be x would be less than negative 2. Keep that in mind. Second question that you're going to need to ask yourself would be, is x on the right? On the, right side. Now, here's the thing, kids. If x is on the right side, that doesn't make sense because we got to go all the way back to English grammar here. I mean, keep in mind, all sentences have the same thing, right? Subject, verb, object. In this order. Well, what would happen if you had a situation where the subject was completely out of order? Well, then if the subject was out of order, then what you would do next is you'd have to rearrange it, right? Now here's the thing. It makes sense if x is on the left, because I'm saying x is more than 4, okay? X is my subject, the more than is my verb, the 4 is my object. Well, what if this is all written out of order? And x is always my subject in algebra, always. I mean, what if I wrote it backwards, like 4 is more than x? Well, then what I'm going to have to do is I'm going to have to rearrange everything. See, so if x can't be my object, x has to be my subject, so I need to write it on the left side, always. And then the subject's going to be on the right. Now, wait a minute. If I rearrange the position of x from the right side to the left side, and I rearrange the position of 4 from the left side to the right side, what am I doing to this inequality symbol? It can't stay the same. I switched everything else. I better switch this too. So, there's 2 questions you need to ask yourself. The first question would be, is x negative? The second question would be, is x on the right side? Now, I'm going to give you these are the 2 questions you must always ask yourself. And I'm going to give you a guide, a kind of a quick way how to remember this. If you answer no to both questions, so no to both, do nothing. If you say yes to one of them, just one of the 2, switch the arrow. If it was pointing left, move it right. If it's moving right, point it left. If it's yes to both, do nothing. So let's actually look at a couple of examples. So let's just say you had 5x, or say negative 5x is more than 10. So question 1, is x negative? Yes. Question 2, is x on the right? No. Okay, I said yes to one of the 2 questions. So I'm going to wind up switching this inequality arrow. So x, isn't going to be more than. I'm switching the arrow now, remember? Negative 2. All right, here's another example. 21 is more than or equal to 7x. Question 1, is x negative? No. Question 2, is x on the right? Yes. So it looks like I said yes to one of the two questions. Let's switch the arrow. I'll make this negative 21. So the first thing I want to do is I want to solve this like it's a regular equation. Then I'll switch. Negative 21 divided by 7 is negative 3. Now I'm going to switch everything. X needs to be my subject. Negative 3 needs to be my object. And I need to switch the direction of the arrow from left to right. That's really all you got to do. Now what if I have a situation that has both? What if I have a situation to where I've got, let's say, 20, let's go back to 21, is greater than or equal to negative 7x. Question 1, is x negative? Yes. Question 2, is x on the right? Yes. Don't change anything in this problem.
No classes the rest of the day?
So I go ahead and cancel my negative 7s. I go ahead and divide 21 divided by negative 7, and I have negative 3. And I won't change anything. And actually the reason is because, well, it actually does change. Here's what actually happens. It's going to change once because x is negative. And then it's going to change again because I have to rearrange x and negative 3. And so if you notice, the arrow went back to its original position. That's why I just say do nothing. Always make sure x is on the left. Always make sure you answer the two questions. And we'll practice that more in class. Now, there's one last part to this. What if I graph? And there's a few graphing symbols here. Okay? You'll circle on a number line, you'll circle a closed dot if it's equal. You'll use an open dot if you just see the arrow only. And you're always going to color in the line, the direction of the arrow. So if I drew a number line, if you drew a number line here, and the cool thing about drawing a number line is you can just write one number for me. So in this case, well, what's x more than or equal to? Negative 3. So that's really the only number I really care about, because everything's going to be relating to negative 3 anyways. So let's see. Is this equal or is it the arrow only? No, it's equal. I see the arrow and I see the little bar underneath. So I'm going to color in my dot. Now see, what direction is the inequality arrow pointing to? The right? Okay, so I'll color the right side. And I'll make sure to color in the arrow as well. Okay, and that tells me that x is greater than or equal to negative 3. So let's try just a few examples of that. So let's say that x is less than 2, okay? So I draw my number line, draw a little tick mark here. It's not really a real part of the line, it just tells me where I'm starting from. Let's see, there's just an arrow only, so I'm going to use an open circle here. And what direction does the arrow point? To the left, so I just color the left part of the line. That's pretty easy, right? If you're asked to graph, graphing isn't too hard with inequalities because they tell you exactly where to color. Let's see. Let's try x equals 3. Okay, I have a open circle. So let's draw our number line and let's use 3. I'm going to put an open circle there. Now, what direction am I going? Well, I'm going to the right, so I'll just color to the right. And then, well, what if I made it x equals greater than or equal to 3? Well, then I just color in this dot. And that's all you have to do when you graph. So remember, color in the number line the direction they tell you to. use a dot if it's equal, use an open circle if it's just the arrow. If x is negative, switch the arrow. If x is on the right side, switch the arrow. If you got, switch everything. If x is both on the right and negative, you don't need to switch the arrow at all. I hope